Remember that you have, if it says like a to the n, or think about like a to the third. A to the third means that you are multiplying a 3 times. The exponent indicates the number of factors of that thing. We call that thing a, the base. The number is the exponent. When you put the base and the exponent together, we call it a power. So a to the third is a power, and it represents the base a being multiplied 3 times. Using that theory, 2 squared times 2 to the 5th means 2 times 2, that's 2 squared, times 1, 2, 3, 4, 5. How many 2's are being multiplied together total? So this is 2 to the 7th. Notice we don't multiply the 2 times the 2 to get 4. All we do is add the exponents. 2 squared, 2 to the 5th, add those exponents together and you get 2 to the 7th. So, number 2, what is number 2 going to be? 2 to the 7th. How about number 3? 2 to the 9th. So, complete this equation. 2 to the m times 2 to the n is 2 to the m plus n. Same thing for the actual property. A to the m plus n. Okay? If you are multiplying with the same base, you add the exponents. Okay, I'm going to write something in here that you cannot do. Well, kind of you cannot do. What if it was 2 to the 3rd times 3 to the 4th? Could you make that be something raised to the 7th? No. 2 to the 3rd times 3 to the 4th is 2 to the 3rd times 3 to the 4th. You can't combine those because they don't have the same base. So in this product of powers property, it's important to notice that you're multiplying powers that have the same base. Okay, number 4. 2 squared raised to the 3rd. If you raise something to the 3rd, that means that you're doing 2 squared times 2 squared times 2 squared. So using what we just learned, 2, 2, 2, the bases are the same, we can add those exponents to give us 2 to the 6th. Now take a look at the exponents 2 and 3. What is the shortcut? Multiply them. So 2 squared squared would end up being 2 to the 4th. How about 2 to the 3rd raised to the 4th? 2 to the 12th. Multiply the exponents together to get your new exponent. So 2 to the m raised to the n is 2 to the m times n, a to the m times n. This leads us into the next one. The next one's called the power of a product. 2 times b squared would mean 2 times b times 2 times b. We're multiplying 2 together twice, so that's 2 squared. We're multiplying b twice, so b squared. Notice what we're basically doing is applying the exponent on the outside of the parentheses to every term inside the parentheses. Now what's important here is that this only works for multiplication and division. So inside the parentheses, you can only have multiplication and division in order to use this property. You cannot do this if it's addition or subtraction. So number 8 would be a to the 3rd times b to the 3rd. 2 to the m times b to the m. The actual property is ab raised to the m would be a to the m, b to the m. Okay, 2 to the 3rd divided by 2 to the 1st. This actually is very similar to the first property we learned today. 2 to the 3rd means 2 times 2 times 2. 2 to the 1st means 2. That one factor of 2 on the bottom will cancel out one factor of 2 on the top, leaving us with 2 squared. Now let's look at the original exponents and find the shortcut. 2 to the 3rd over 2 to the 1st. subtract those exponents. 3 minus 2 is 2. So the shortcut here is you subtract the exponents. 2 to the 5th divided by 2 squared. What are you going to be left with? 2 to the 3rd. And if you need to think about it, you have 2 to the 5th, that's 5 of them on top. 2 squared, that's 2 of them on the bottom. 2 on the bottom are going to cancel out 2 from the top, leaving you with 3 left over. 2 to the 6th over 2 squared. What's that going to give you? 2 to the 4th. So the shortcut, the property is 2 to the m minus n. Now again, the bases have to match. Notice your bases are always matching. So if you were to have something like 2 to the 3rd over 5 to the 2nd, that would simply be 2 to the 3rd over 5 to the 2nd. You can't use this property when the bases don't match. 3/4 squared. If we think about what does a square mean, it means we're taking 3/4 times itself. This means we have 3 squared on top and 4 squared on the bottom. So notice what we did is we applied the exponent of 2 to everything inside the parentheses. Now again, this only works if there's multiplication or division inside the parentheses. If it's addition, you can't do it. So if it's something like x plus 2 squared, that means x plus 2 times x plus 2, and you'd have to double distribute or FOIL. You can't just do x squared plus 2 squared. It doesn't work when it's addition and subtraction. This property only works when it's multiplication or division. Using what we now know, 3/4 to the 3rd would be 3 to the 3rd over 4 to the 3rd. So this would be 3 to the, I don't know where my pen went. Pen, hello. 3 to the m over 4 to the m. The actual property, the power of a quotient property, says that if you have ab raised to the m, you have a to the m over b to the m. We are going to jump over number 14 and do the next property and then go back to number 14. I think it makes more sense to do the zero exponent property before the negative exponent property. If anyone has a calculator laying out on their desk right now, please try 5 raised to the 0. 1. So 8 to the 0 is 1. Negative 3 to the 0 is 1. Anything raised to the 0 power is 1. The zero exponent property says anything raised to the 0 power is 1. Okay, 2 to the 4th is 16. 2 to the 3rd. 2 times 2 times 2 is 8. 2 squared is 4. 2 to the 1st is 2. We just learned that 2 to the 0 is 1. Okay, now, take a look at the pattern that's occurring here. As we decrease the exponent by 1, we are dividing by 2. So, what is 1 divided by 2? 2 to the negative 1 is 1/2. 2 to the negative 2 is 1/4. 2 to the negative 3 is 1/8. Now, I'd like you to rewrite it this way. 1 over 2 to the 1st. 1 over 2 squared. 1 over 2 to the 3rd. Notice the negative exponent flips, it takes the reciprocal, and it becomes 1 over that term without the negative. So the rule here is negative exponents move. Negative exponents take the reciprocal. Negative exponents move. 2 to the negative n is 1 over 2 to the n. So the true rule is, the negative exponent property says a to the negative m equals 1 over a to the m. Now up in this space, I'd like you to write that again bigger. A to the negative m equals 1 over a to the m. If you happen to start out with something like this, a negative exponent on the bottom, what do you suppose is going to happen to that negative exponent on the bottom? It's going to be a to the positive n. This says evaluate the expression, which technically means you should plug it in and get an actual number answer. But what I really want to see is that you know how to use the properties. So I don't want you to plug this into your calculator. I want you to write what the result of using the properties would be. The person who made this notes packet said, tell which properties of exponents you used. Technically, that means you'd have to write a proof. You'd have to write each step and write which property you used. I don't care if you know the names of the properties. I want you to be able to use them correctly. So let's skip that writing which property. The important thing is I want you to show your work. There are multiple ways that you can get the correct answer. I want you to show your work. So 6 squared times 6 to the third, same base. So we do what with the exponents? Add them. This would be 6 to the fifth. Done. The next one. What I'm noticing here is we've got 9 squared raised to the negative third. I want to deal with that first. Sorry. So 9 squared to the negative third, we would multiply those exponents, and that would become 9 to the negative 6. Now in front of that, we have 9 to the positive 6. So now we add those exponents, and we get 9 to the 0, which is 1. Okay, the next one, I'm going to focus on the square before we do anything else. So this is 1/2 squared. That means we've got this 3 over 2 to the negative 1, 1 squared over 2 squared. Now, on the bottom, these are being multiplied. So we can add those exponents. What is negative 1 plus 2? 1. So this is 2 to the 1 on the bottom. And on the top, we have 3 times 1 squared, but 1 squared is just 1. So this answer is 3/2. Turn the page. Oops, we have one more example. 3/5 raised to the negative 2. Using the property about parentheses, you take that negative 2 and apply it to everything inside the parentheses. So 3 to the negative 2 over 5 to the negative 2. The 3 to the negative 2 in the numerator is going to move to the bottom and become 3 squared in the denominator. The 5 to the negative 2 in the denominator is going to move and become 5 squared in the numerator. So our answer is 5 squared over 3 squared. Okay, number 22, 7 to the negative 5th over 7 to the negative 3. Because the bases are the same, what can we do with the exponents? Subtract them. So 7 raised to the negative 5 minus a negative 3, which is 7 to the negative 2. Which becomes 1 over 7 squared, or 1 over 49. There is another way you could do this problem. You could say, hey, 7 to the negative 5th, that becomes 7 to the 5th on the bottom, and that becomes 7 to the 3rd on the top. So these 3 on the top are going to cancel out 3 of the 5 on the bottom, and we're going to be left with 2 factors of 7 on the bottom, and no factors of 7, or the identity 1, on the top.